Hey, this is John. I just want to make a little video to show off a funny little side project I did for a class called Emerging Languages. Basically, the point of the project is I did it with a partner, and I wrote the game of life aspect of it. It's basically just you get assigned a language, and you just have a couple weeks to just go in and see what it's all about and make a little project about it. So we got assigned Julia, and I decided to make the game of life in Julia. If you don't know about that, it's John Conway's game of life, and it's pretty simple. There's just a bunch of cell blocks. You either have an alive cell or a dead cell, and this is kind of the rules. So each cell with no neighbors dies. So you can see an example here. There's a neighbor. There's a cell right here has no neighbors. It just dies. But if you have 4 or more neighbors, you also die. So if you're overpopulated, you're also going to die. And then each cell with 2 or 3 neighbors survives. And then if you're a dead cell is like the video game. I'm sorry. If you're a dead cell and you have 3 neighbors, you become populated. So you exist, I guess. And basically with those 3 or 4 simple rules, you can make really cool looking animations basically. So yeah, let me just run through the code. It's pretty simple. I mean, here we're just generating a matrix, and basically all that does is it just, in Julia, this is it's a 1 line to generate a 2D matrix. So this 1-liner generates a 60 by 60 matrix, which is just really cool. This is just a spawn chance variable. And then you basically go in, you make a random chance, and then if the chance is greater than or equal to the spawn chance, so in this for instance, it would be there's a 20% chance each cell will be an alive cell. And a live cell is just set to 1 in the 2D array, and then just returns it. So then it goes through n times and actually generates a heat map, which is a type of plot in Julia. Julia has a lot of great built-in plots. And I think they're designed to be for statistical analysis, but I use them to animate something, which is pretty funny. Probably not their intended use case, but I think it's funny, so I did it. And basically there's the animates it using a macro. So a macro in Julia is kind of meta programming. That's kind of a stupid way to explain it. I won't be able to explain it very well, but basically all it does is it adds the code that would be needed to generate an animation for you, but after it compiles. I don't really understand it very well, but basically all I know is it animates it. Oh my god, what have I done? So basically it goes in, it makes a deep copy of the matrix. Because in Julia, if you just made a regular copy of the matrix, things would go bad, because I think it would copy just the reference of it. It wouldn't actually make a new copy of it. And then it's pretty cool. You can loop through the X and Y coordinates of your 2D matrix using one thing called Cartesian indices. It's really cool. I found it on this website. I can probably link this just to you can check it out. It's a really great article. Definitely worth a read if you're really into Julia and you want to have some weird ways to looping through stuff, because it's pretty cool. They do some pretty cool stuff. But anyways, gets the neighbors using a neighbors helper function, which is pretty much just if you ever use Python's God, what is it called? Where you do a for loop in 1 line. It's that just in Julia, which is pretty nice. And then it goes through each of the neighbors. It gets the neighbor count, and then it assigns it. So if it's an alive cell, it'll kill the neighbor or kill the cell if it has less than 2 neighbors or greater than 3. And then if it is dead, it will make a new cell if its neighbor count is greater than or equal to 3. And then basically it sets the matrix equal to the new matrix you already made that it deep copied. And then we, at the end of all these loops, after the animation loop, you can literally just generate a GIF function. It's literally built in. So it's really cool. It's really cool. Okay, now to the actual fun part. I know that's the boring part. I know the boring part of coding is coding, but it's also the fun part. It's weird. I mean, looking at other people's codes is boring, but looking at your own code it's fine. Okay, I'll shut up. So I'm gonna hit run, and Julia's pretty nice, where like it has like a REPL system, but like the first time you actually run it, you have to like wait for the REPL to start up, which is pretty annoying. But like once the REPL actually starts up, it's actually pretty fast, which is nice. I say that as it, oh, there he goes. Okay, and then it literally just makes a GIF and pops it up for you. And I just think it looks cool. Just see all the guys moving around. Cells, yummy cells. And that's pretty much it. Honestly, it just makes a GIF, and eventually it'll loop. I don't know when it loops. I think it's like 30 seconds. Oh gosh, I don't remember. Anyways, yeah, just nice to look at. I'll zoom in. But this isn't the cool part. This is like cool, but like the cool part is when it didn't work. That was when the funny stuff happened. So where am I? Don't mind my really unorganized desktop. So the cool part was when it wasn't really working. So I think this is just, hold on, it won't open in this. The funny part was when it wasn't working and it made some really weird stuff. So I'll show you this one. This one is like, I don't even know. I'll just let it explain itself. But basically it starts off really slow, and the neighbor count for when a cell dies is wrong. So it'll literally just like slowly like evolve and take it over. It's almost like, you know, if you like put bacteria in a petri dish, it just like over time will like consume the whole petri dish. I just thought it was really cool. And like, I don't know, I think the whole point of the game of life is to like use really simple rules and really simple algorithm to like emulate life. And I thought that just does it really well. Gets a little weird at the end with like the weird flashing lights, but you know, it's cool. And then the other one, okay, if you are bad with flashing lights, do not watch this. Please stop. This is your warning. Because this is gonna flash really bad. It kind of hurts your brain, but you know, for me, it hurts my brain in a good way. Yeah, okay, here we go. Yeah. I genuinely don't know why this works this way, but it looks kind of cool and trippy. It almost looks like a shark. I don't know if you can see that. That doesn't make any sense, but it looks like a little guy. And then like if you go on, it like changes. I don't even know how to describe it. It's weird. It's almost like it's like the effect of when you get struck by lightning. Not really though. I don't know what I'm talking about. Anyways, I just thought it looked cool. And then this is what I had like kind of before, where it's pretty similar to what the working looks like, but it's just, it slowly dies instead. But you can see there's a bunch of weird jitters, and you can see like this is not proper game of life behavior. Like if there's like a block here like that, it would just stay as a block of 4. It would not be like rotating like that. Yeah, so hopefully you enjoyed that as much as I did making it. And I'll leave you with this as I sign off. Adios.